Hello, good morning all. Today we'll discuss about Kirchhoff laws in current electricity. So what is the application of these Kirchhoff laws? These Kirchhoff laws are used to calculate the current in a given electrical network, and we can calculate the potential difference between any 2 points. EMF of the given cell we can also calculate, and internal resistance of the battery also we can calculate by using of these Kirchhoff laws. So we have two Kirchhoff laws. This is the first one. First Kirchhoff law, or also known as current law. Current law, or also known as junction law. Right? So the junction law we can apply at the junction of the electrical network. So it is junction law and is related to current, so it is known as current law. So what it states? See, according to Kirchhoff's first law, the sum of currents flowing into junction is equals to the sum of currents leaving the junction. The currents flowing into junction is same as the sum of currents leaving the junction. See this diagram, I1, I4, I5 are flowing into junction, and I2, I5 are leaving the junction. So according to this Kirchhoff first law, the sum of currents flowing into junction, nothing but there are three currents flowing into junction, I1, I4 and I5, which is equals to leaving the junction, two currents are leaving from junction, I2 and as well as I3. The junction, it is also known as node. Node is nothing but junction. Right now bring this I2 and as well as I3 in this side, that is I1 minus I2 minus I3 plus I4 plus I5 equal to 0. Right? The total current becomes 0. The total current at the junction equals to 0. The currents flowing into junction are taken as positive, and the currents leaving the junction are taken as negative. This is a sign convention. When you are using this Kirchhoff first law, we must apply this sign convention. Flowing into junction taken as positive, these are positive currents into junction. Leaving the junction taken as negative, or the total current at the junction is equals to 0. The total current at the junction equal to 0. So according to the Kirchhoff first law, the sum of currents into junction is equals to the sum of currents leaving the junction, or the net current at the junction is 0. Right? Now see one more, and this Kirchhoff current law or junction law explains or is the consequence of conservation of charge. The total charge remains constant, neither charge be created nor be destroyed. The total amount of charge remains constant. How much of charge flowing through the junction is same as the charge leaving from the junction. Total charge remains constant. So how the question will ask on this? See this one problem, a simple problem I am going to explain. So in this diagram, 5 ampere of current flowing into the junction and 2 ampere leaving the junction, and the remaining current becomes 5 minus 2, which is 3 ampere is flowing towards the next junction, and 1 ampere also flowing towards the junction. So I is a current leaving the junction. According to Kirchhoff's first law, the sum of current leaving the junction equal to sum of currents flowing into junction. So I can be written as 3 plus 1. So the total current I becomes, it is 4 amperes. Okay. So now we'll discuss about Kirchhoff's second law, or also known as loop law, because we can apply entire loop or circuit, also known as voltage law, because it deals with potential differences in the circuits. So what it states, Kirchhoff's second law. See in this diagram, in circuit diagram, the potential or EMF across the battery is Vs. Across the first resistor, the potential difference is IR1. It is taken as V1. Across the second resistor, the potential difference it is IR2. It is taken as V2. So according to Kirchhoff's second law, the algebraic sum of potential differences in closed loop equal to 0. Nothing but it is Vs across the cell, and first resistor it is V1, and second resistor it is V2 equal to 0, or sigma V equal to 0. The algebraic sum of potential differences in closed loop equals to 0. But we have some application, we have some conditions to apply this second Kirchhoff law. What are those conditions? So what are those conditions or sign conventions to apply this Kirchhoff's second law or loop law? See, this is a resistor, or if current flows from point A to point B, is the direction of current, and this is same resistor or and point A and point B, the direction of current. If you are measuring the potential difference in the direction of the current, if you are measuring, then the potential difference it is taken as negative. In the direction of the current, the potential difference it is taken as negative. If you are measuring the potential difference opposite to the current, then the potential difference it is taken as positive. Right? So the current, in the direction of current, if you are measuring, potential difference it is negative. In opposite direction, the flow of current, if you are measuring, the potential difference it is taken as positive. This is in the case of resistor. Now in the case of battery, right, this is a point A and this is point B. So if the current, if you are measuring the EMF, now negative potential to positive potential, then the EMF or potential difference across the cell, it is taken as positive. If you are measuring the current or high potential to low potential, then the potential difference it is or taken as negative. EMF or the potential difference across the cell it is taken as negative when high potential to low potential. In this case, low potential to high potential. Here, low potential to high potential. The potential difference it is positive, and high potential to low potential. Then the potential difference it is taken as negative. Okay. So then how we can apply this Kirchhoff law for given circuit? So just now I said across first resistor it is V1 and second resistor potential difference it is V2. Now you are moving right from positive plate of the battery or high potential, and in the direction of the current you are moving, so it is negative, and also across second resistor in the direction of the current, so V2 also negative, and the current it is flows from low potential to high potential across the battery, so this is positive. So the potential difference can be written as in a closed loop plus Vs minus V1 minus V2 equal to 0, or Vs equal to V1 plus V2, Vs equal to V1 current into resistance, and across second resistor current into resistance. So Vs is equals to I of R1 plus R2. Okay, so this is the application, means how to apply the sign conventions for Kirchhoff second law. Thank you, and please subscribe and support my channel. Thank you all.